Hi students, welcome to S&M Coaching Center. Today in polynomials, let us start with the first sum. Find a quadratic polynomial if the sum of the zeros and the product of the zeros are -1 and -20. So what is that they have said? Sum of the zeros is -1, which means alpha plus beta is equals to -1. The product of the zeros is -20. Alpha beta is equals to -20. They asked us to frame a quadratic polynomial. So, you write this expression. P of x is equals to x square minus alpha plus beta into x plus alpha beta. This is how we frame a quadratic polynomial. Just substitute the values. X square minus alpha plus beta is -1. So write that -1 in the bracket plus alpha beta is -20. So -20. So the required polynomial is x square plus x minus 20. The required polynomial is x square plus x minus 20. Now there is a second part to this question also. His question is find the zeros of the polynomial so obtained. Now we have the polynomial. They are asking us to find the zeros of this polynomial. So which method we will apply for this? It is the splitting of the middle term. So how do we do that? First multiply the first term and the last term. So we are looking at factors for what is the coefficient of x square? 1. So 1 into -20, -20 x square. So basically we are looking at factors of 20 x square. Do not bother about signs. I will tell you how to keep the signs. We are basically looking at 20 factors such that when you multiply the factors, you should get your 20x square back. When you add or subtract, you should get the middle term, which is 1x again. So that is the condition. Let us check the factors. What are the factors of 20? Let us write all the set of factors of 20. 1 and 20, 2 and 10, 4 and 5. These are the possible set of factors we have for 20. So let us see. When we multiply 1 and 20, do we get 20? Yes. But when we add or subtract, do we get 1? When we add 1 and 20, we get 21. When we subtract, we get 19. So the addition or subtraction would give us 21 or 19, but not 1. So this set of factor is not suitable. Next one. 2 and 10. When we multiply, we get 20. When we add, we get 12. Or when we subtract, we get 8. We are not getting 1 again. So this is also a wrong set of factors. Next one. When we multiply 4 and 5, yes, we are getting 20. When we add, we are getting 9. But when we subtract, we are getting 1. So which means 4 and 5 are the correct set of factors. So the factors are now written as 4x and 5x. Next, now we have settled the factors. Now we found out the factors. What is left over? We have to give the appropriate signs. Now see children, what are we doing to the factors? Are we adding or are we subtracting? Yes, we are subtracting the factors in order to get the middle term. Whenever you are subtracting to get the middle term, whatever is the sign of the middle term, what is the sign of the middle term? Plus sign. Give the sign of the middle term to the bigger factor, the opposite sign to the smaller factor. So now our factors are ready with the complete signs. -4x and +5x are our factors. Now, next step is write the first term as it is. Now, instead of the middle term, remove the middle term along with its whatever is the sign, and in place of the middle term, keep the required whatever factors we got, keep those factors. You can write -4x or +5x first. It doesn't matter which factor we are writing first. So, I will write it as minus 4x plus 5x. So what did I do? I replaced the middle term with the factors. Write the last term as it is. Then you have four terms now. Take a common from the first two and the last two terms. What is common in the first two terms? X is common. So take x common out. I am left with one x. Keep the sign whatever. From 4x, I have taken x. So I am left with just 4. Keep 4 inside the bracket. Then what can you take common from the last two terms? I do not have x in 20, so I cannot take 20 common. But both the terms, what is the common? It is 5. Since this term is beginning with the positive sign, I take plus 5 common. So whatever is left over from plus 5, x is left over. Whatever is the sign, minus, keep it. 5 4s is 20. So I will write 4 inside the bracket. Now I have two terms and in both the terms x minus 4 is the common factor. If you are getting a common factor like this same in both the terms, which means your factorization is correct. Then instead of writing the common factor twice, write it once and in another bracket, make x plus 5 as the second factor. This is the factorization of the whatever quadratic polynomial you have framed. Now, what is the question? After getting the factorization, what we have to do? Equate it to 0. When we equate it to 0, we can find the zeros. This means x minus 4 is equals to 0 and x plus 5 is equals to 0. Once you get the factors, equate them to 0 and get the value of x. So x is equals to 0 and x is equals to minus 5. That what does it mean? It means that the zeros, what are the zeros? Alpha is equals to 4 and beta is equals to minus 5. The second question, children, find a quadratic polynomial if the zeros are 2 over 3 and minus 3. Also, we have to verify the relationship between the zeros and the coefficients. So now what is that? What are 2 by 3 and minus 3? They are just the zeros. So what is given? Alpha is equals to 2 by 3 and beta is equals to minus 3. So we have to frame a quadratic polynomial. For that, first find alpha plus beta, which is 2 by 3 plus of minus 3. This can be written as 2 by 3 plus into minus is minus 3 and 3 can be written as 3 by 1. So take LCM. What is the LCM of 3 and 1? 3 and 1 LCM is 3. Think like that. 3 multiplied by what will give you the LCM? 3 multiplied by 1. So multiply its numerator with 1. Then 1 multiplied by what will give you the LCM? 1 multiplied by 3. So multiply its numerator with 3. Then 2 ones, it is 2 minus 3 threes, 9. So what is the sum of the zeros value? It is minus 7 by 3. Similarly, find product of the zeros. Product of the zeros is 2 by 3 multiply with minus 3. 2 by 3 multiply with minus 3. Remember children, in multiplication there will not be any LCM. First see if you can cancel the numerators and denominators. Yes, 3 and 3 can be cancelled. So I am left with 2 and minus 1. 2 into minus 1 will be minus 2. So the product of the zeros is minus 2. Now what is that we have to do? We have to frame the quadratic polynomial. So P of x is equals to x square minus of alpha plus beta into x plus alpha beta. This is how we will frame. Substitute the values. X square minus, what is alpha plus beta? It is minus 7 by 3. So write minus 7 by 3 into x plus of alpha beta is minus 2. Keep in the bracket minus 2. So this will be x square minus into minus plus 7 over 3 into x, then minus 2. Minus 2. What is the denominator? So in order to remove the denominator, what we have to do? What is the denominator here? Denominator is 3. So multiply the whole equation with 3. So multiply the whole equation. In order to cancel the denominator, what we have to do? Multiply the whole quadratic polynomial with 3. Multiply it with 3. So x square into 3 will be 3x square plus 7x by 3 into 3 minus 6. Now if you notice, 3 and 3 will be cancelled. So what is the required quadratic polynomial? It is 3x square plus 7x minus 6. So when zeros are given, first find alpha plus beta and alpha beta, then frame the quadratic polynomial. Now to verify the relation between the zeros and the coefficient, let us write the whatever quadratic polynomial we framed and then alpha beta and then alpha plus beta. Now he is asking us to verify the relationship. Now when you got the quadratic polynomial, what is the value of a? A is the coefficient of x square. So it is 3. What is value of b? B is 7. Coefficient of x. Constant is c, which is minus 6. Now how do you verify the relationship? Alpha plus beta. What is alpha plus beta? Alpha plus beta, we got it as minus 7 by 3. What is, write the minus as it is. What is 7? 7 is b. B by, what is 3? 3 is a. So you verified the relation that alpha plus beta should be equals to minus b by a. The next one. So alpha beta is equals to, what is equals to c by. Now we have to show that alpha beta is equals to minus c by a. Now we know the relationship alpha beta is equals to c by a, which is, what is c? Minus 6. What is a? A is 3. So 3 ones 3 2. So we proved that alpha beta is equals to minus